What shall I discuss? Fungi?
Yeah.
Okay. But I don't know of any fungi like I just described that affect non-insects. They all seem to affect insects.
All of them?
Yeah, all the fungi that do that affect the brain. There are infective agents that do affect mammals like us. For instance, there's one that infects mice and makes them a little bit fearless, so the cats will eat them.
And then there's the kind of mushrooms that some humans eat.
That's kind of mushrooms that what?
Humans eat.
Even me?
Humans eat?
Humans eat? Do you eat mushrooms?
Yeah, don't you?
Oh yeah, I do, yeah. Mushrooms are more closely related to animals than to plants.
Really?
Yes. If you go back into history, you find that we have a common ancestor with mushrooms.
I think I remember that from bio.
But are you familiar with slime molds? They're the most amazing thing.
No.
Okay. They look like bacteria. They look like, sorry, how do you say amoeba in English?
Amoeba.
Amoeba. They look like amoebas, and they go around eating bacteria. But then when there's a shortage of food, a whole bunch of them get together and pile up on each other and form a stalk, and at the top, the ones on top form a fruiting body, which makes spores, which gives off. That means that the ones on the bottom are cooperating in this mission of spreading the race by forming a stalk that sends out spores, but they get nothing out of it. They're just holding up the other guys who are going to have descendants.
That's kind of cool.
Yeah.
Awesome.
And slime molds have a sort of collective intelligence too. If these apparently free, independent amoebae are in a petri dish and they're concentrated at one end, they will form a trail directly to food on the other end. The shortest path to get there.
They sound pretty smart.
Yeah.
Cool.
And what do they look like? Just like a white blood cell.
That's cool.
As a matter of fact, there's a problem that mathematicians really can't solve completely for difficult cases, called the traveling salesman problem. Are you familiar with that?
No.
It's if you have a map and it shows a bunch of places on it where a traveling salesman has to stop, calculating the least expensive path that takes you to all the places without wasting time going off. That's called the traveling salesman problem. And mathematicians can't solve it in general, but slime molds can solve it.
What?
What you do is you put a little bit of food at each spot that the traveling salesman has to visit, and they form a path that's the most economical path connecting all those places.
That's pretty cool.
So if you by cool you mean smarter than mathematicians. Yeah.
Yeah, sounds like we have a lot to learn from them.
Yeah.
Have you been doing any new research lately?
Well, I had a letter published in Science magazine recently pointing out that what people think is the best body mass index isn't. Better body mass index is... I didn't send you a copy of it.
Alright, isn't that like the book you're writing?
Isn't that like what?
The book you're writing?
Well, I'm going to put that in there.
Okay.
But I'll get the science article. At no extra charge, I'll get you a copy of that.
Oh, thanks, Grandpa.
You're welcome.
How's your book going, by the way?
I'm not working at all on putting it together. I'm just piling up tons of stuff to put in it.
Alright. Cool. Are you working by yourself on it?
Yeah.
Cool.
About slime molds, I had a letter in New Scientist magazine, a very good British magazine about slime molds. They had an article on slime moles, and they said something about how it traced the traveling salesman problem on a map, and these particular ones were yellow. And I said I'd seen these yellow lines on the road, but I thought they were road markers. I didn't realize it was slime moles
Oh yeah,
tracing the traveling salesman.
that's funny.